Hello. Today I'd like to show you how we can use chi-scan and integrated EDS and EBSD data to resolve crystallographically similar phases for more accurate microstructural characterization. So I have here a data set that was collected. If we look at the image quality map, we'll see the microstructure here. It's an interconnect device for a microelectronic circuit. If we look at the orientation map, we see that we resolve the grains nicely. We see the microstructure. But if we look at the phase map, we're going to see it's very noisy, and that's because one of the phases is an austenitic iron nickel phase, another one is a copper phase, but both of these phases are face-centered cubic, and that means that the EBSD patterns for these two phases look very similar for any given orientation, and it's difficult to differentiate these with traditional Huff-based pattern indexing. So what we can do, we can use EDS information. If we look at our EDS maps, we will see that we can see very clearly where there's a copper-rich area, where there's an iron-rich area. So to do this, what we can do is we select our peak here. We'll have our Huff point. So as we click here, you'll see we see a reconstructed pattern based on the saved Huff peak positions. We can go here to our chi-scan button. This will use the spectral information to find the different chemical-based components in the microstructure. So we press this and we see here in this little image here, the red, if we look on here, it's the iron nickel phase. So we will select and say this represents the austenite. So when we're at this particular pixels, we will use the austenite material file to select the phase. In the yellow, we will use the copper. We'll select that there. These other phases are just noise phases at the end. We're not really going to worry about those because they don't produce any usable EBSD patterns. So we've defined our phases with the chemistry. So now at each point we'll select the phase with the chemistry and then determine the orientation and the misorientation information via EBSD. So we'll hit go. With the Huff peaks here, you'll see it reprocesses very quickly. And when that's finished, we can close this window. We'll see we now have this rescanned area. So if I look here, again, our image quality map, it's going to look better. Our orientation map looks well. And then when we put our phase map up here, this is where we're going to see a much more clearly resolved phase structure compared to this phase structure. And that's the comparison I want to show you, to show how quickly and easily chi-scan can be used to remove the noise from your phase differentiation, to clearly differentiate phases and give accurate microstructural characterization.